Okay, so for 1a, the domain of the function is going to be all real numbers because you can plug in any number for x and still get a value for y. For 1b, you have to check these two rules here. Does f of x equal f of negative x, and does f of negative x equal negative f of x? So I checked them over here. Since neither of those were true, this function is neither odd nor even. To find the rule for the inverse, we're gonna flip x and y and then solve for y. So everyone's might look slightly different, but it should look something like this. If you have it in a different form, that's fine. For number 2, we have to use these two rules. If it's an even function, then if you have the point AB, then you're also going to have the point negative AB. If it's an odd function and you have the point AB, you're also going to have the point negative A, negative B. So you just use those two rules to answer this part. Number 3 is a piecewise function. So to graph f, basically you're going to start at x equals negative 4. When x equals negative 4, you're going to follow the first rule. So negative 4, I plug that into x minus 2, and I get negative 6 for one of my points. If I keep moving to the right and I try negative 3, I'll get negative 5 for my y value. Negative 2, negative 4, and so forth until I get to negative 1. At negative 1, that's when I switch and I start using this second rule. So in that case, when I plug in 0, I'll get negative 4 because I'm using the second rule now because I'm between negative 1 and 2. So that's how we end up with this graph where we have a line from negative 4 to negative 1 and then a parabola from negative 1 to 2. If you're in section 4 on your test, you had just a greater than sign. So, or you had just a less than sign there. If it's less than or equal to, you're going to have a solid dot here. If it was just less than, you have an open dot here. Okay, so we're going to use our graph to answer the rest of these questions. If we want to find f of negative 2, we're going to use that first rule because negative 2 is between negative 4 and negative 1. So f of negative 2 is going to be negative 4. Find the zeros of f. We want to know when f, or our graph, equals 0. So that's when it's crossing the x-axis, and that's happening at x equals 2. For section 4, you guys had a greater than, or you had a less than sign here, not a less than or equals 2 sign. Therefore, there are no zeros because this is an open dot. So it's not technically part of the function. For section 2, this was a closed dot, and the answer was x equals 2. For section 4, there was no answer. Okay, for D, we want to find the range of f. So that's all the possible y values. We're basically going to take the lowest y value here, which is negative 6, up to the highest y value, which is 0. A lot of you found the domain instead, which would be all possible x values, and the domain was negative 4 to 2. We're looking for the possible y values. Okay, and then f of 1. We find f of 1, we use that second rule because 1 is between negative 1 and 2. So f of 1 is negative 3, and then we find f of negative 3 is negative 5. This one looks really similar to a lot of other problems that we did. So if we want to find the domain of the function, we're looking at this radical, and we have to recognize that the expression underneath the radical has to be greater than 0. Greater than or equal to 0, so x minus 3 has to be greater than or equal to 0, therefore x has to be greater than or equal to 3. For the range of the function, you can look at our graph here. It's always going to be greater than 2, because say we plugged in our lowest possible x value here, we would plug in x equals 0, we get our lowest possible x value is 3, so we plug in 3 minus 3 plus 2, our lowest possible y value is going to be 2. The parent function is the square root, which is y equals square root of x And then we have a horizontal translation of 3 to the right and a vertical translation 2 up. And your graph should look like this. We know that the inverse of f is a function because it passes the horizontal line test. And then to graph the inverse of x, you shouldn't have to find the equation. You just can follow the rule that we learned, which is you switch the x and y coordinates from your original graph. So now instead of 3, 2, I'm going to have 2, 3, and so forth. So your graph should look something like this. Then in f, I asked to actually algebraically find the rule that goes along with this graph. So to do that, we're going to switch the y and x value again, solve for y, so that's what I'm doing here. And eventually I'll get x minus 2 squared plus 3 equals y. Now, if I were to graph that, we could see that's a parabola. That's going to be quadratic because there's a square. So it would look like this. But we already know from E that we only have half the parabola in our problem. So we have to make sure we limit this parabola. There was a homework problem like this, but this is probably the trickiest problem on the test. We have to limit our parabola by saying x is greater than or equal to 2 because we only want half that parabola. We don't want that full green parabola. Okay, here, if we want to graph, I gave you a graph. If you want to graph the absolute value of f of x, you're basically going to reflect anything that has negative y value over the x-axis. A lot of people just connected this line like that without realizing you had to go back down to the x-axis because it's supposed to be a mirror image. So we reflect whatever the negative y values were over the x-axis for that first part. For the second one, we basically get rid of this half, we forget about it altogether, and then we reflect this over. We reflect our everything on the right side of the y-axis over the y-axis. Okay, here is it even, odd, or neither? You should know by looking at the graph that it's even because it's symmetric across the y-axis. And then you should be able to recognize the shape of this graph as a V, so the parent function is the absolute value function. Writing a rule for f of x basically means you have to figure out what transformations happened and then write the equation. So this might take a little bit of guessing and checking for people, but you should be able to figure out that there was a vertical reflection because the V is now upside down. It looks like it was the V usually looks like this, and this purple V is a little bit skinnier, which means that there was a dilation. And we can see that we went from the point 1, 1 to the point 1, 3, therefore a dilation of 3, a vertical dilation of 3. And then finally we also shifted everything up 3 units. So this one is also difficult. This was a hard one. Takes a little bit of guessing and checking. I didn't take off too many points if you were a little bit off. And then finally, this is one that was a little bit new looking, but suppose we have a function with a domain of -3 to 2 and a range of 0 to 4. If you get confused by this, you could just graph it out. So let's think of an example. Like maybe you just have this line. That's a function with the domain -3 to 2 and a range of 0 to 4. Now, let's say this is f of x, then now I want to actually graph f of x plus 3. Well, you all know that this is a horizontal translation to the left 3, so we're going to look something like this. Now, you're trying to figure out what the domain and range are of this new function, of this red line. And if we move to the left 3, that's going to affect our domain, but that's not going to affect our range. So our domain, both endpoints of our domain are going to move to the left 3. Our range is going to stay the same. So if we think about 7b, again, now we still have that, let's still take that same example of this f of x. Now we have 3 f of x. When we have, that's a vertical dilation. So all of our y values are going to be multiplied by 3, that means. So if I multiply 0 by 3, I'm still going to get 0. If I multiply 4 by 3, I'm going to get 12, which is how I end up with 0. Is less than or equal to y is less than or equal to 12 as my new range. It would look something like this. However, the domain's not going to change because vertical dilations don't affect the domain. They don't affect the x values, they only affect the y values. So this one was also a little tricky because we hadn't seen something like it before. If you have any questions still, please reach out to me.